IVM.
Hi everybody, just wanted to ask everyone for a quick favor. We're running a brand survey right now and would really appreciate it if you could let us know what you think about the advertising on IVM. Go to ivmpodcast.com/survey and do let us know. As part of this, we'll be selecting 10 random participants and sending them some IVM swag, so do fill out those surveys.
Yes.
I saw that happening when he was at 1. I was like, किसी ने तैयार नहीं किया है.
Yeah, exactly. So we decided to do a cold open. This is Simplified, trying to be a little more like SNL.
Oh, wow.
So next time we'll just start talking. None of this hello, welcome to Simplified. We'll just jump right into the topic.
But like YouTube videos do, na? They take the juiciest part and do a 5-second preview up front and then get into the beat of it.
Yeah. And now the music will come in.
Yeah.
For Simplified. By the way, guys, I have a question for you before we begin. 92.4924%. What am I talking about over here? We were
your board exam marks.
Your board exam marks. Actually, not too far off the mark, actually. Actually, no. So just before we start recording our episodes, our long-suffering audio engineer, Deep, asks us what level is your Zoom mic level at. So I actually calculated. I took a screenshot and put it into MS Paint and calculated with the ruler tool. So it's 308 pixels divided by 333 pixels. So that's 92.49%.
Hey, I love how you used MS Paint. It is the most versatile.
Cutting-edge software. Yeah.
It's interesting how somehow or the other, with our random openings, we still managed to find a decent enough segue to the topic at hand.
Yeah. Just before this, we asked Deep, is it good? Is it excellent? And Deep was like, it's satisfactory.
It's satisfactory.
Which is also what the level we aim to be at.
This is a satisfactory podcast.
We
are not going for seen and the unseen, like Tim Ferriss stuff. All of that stuff we're not going for. We're going for satisfactory, right? Like we are at that good, comfortable level where you listen and you only feel partially bad for wasting an hour.
Yeah, correct. So this is a plug for the other episode that we're going to record today and my new show. But when I spoke to Rohan about how he used to do well in school and all that, Rohan Joshi, Rohan Joshi, the comedian. I asked him how he was at school and all that. He said he was never a front bencher and he was never really a back bencher. So he was sort of like in that weird place in the middle. Yeah, the middle bench. So I told him we should probably start a show like Tales from the Middle Bench or something. So it feels like we are something like that. Like things is the Middle Bench Incorporated. I like that as a company. I like that as an LLC. I think all just the satisfactory things. Like
this is a shout out to everyone who's the middle bench in life, right?
Yes.
All the front benchers are the stars, all the back benchers are the cool badasses, and you are neither.
But there is a scope for a WhatsApp profundity here, right? What is life? I mean, basically we are the satisfactory ones. So that's what you should aim for.
This reminds me of I think when Jamie Carragher, so for football, Jamie Carragher and what's his name? Gary Neville were having a conversation and Jamie Carragher, particularly Gary Neville and Jamie Carragher have this banter going. Jamie Carragher is a centre back and Gary Neville is a full back. So he's like, the thing is, full back is actually either a failed winger or a failed centre back, right? And so therefore, nobody wants to grow up to be a fullback. Nobody wants to grow up to be a Gary Neville. So that's what I feel in some ways this analogy gets applied to a lot of different parts of life where you're failed at two different things and therefore ended up in the certain part of your career. Like I feel, especially with advertising, like if you're a failed creative and a failed business person, then you've ended up as a planner.
I love this. I love this because usually when we talk about success, we are talking about take two things that you are successful at and see what the intersection is. Now we're like, take two things that you failed at and put together. Which for me,
but here I'm going to interject with a profundity of my own making. Is that nobody is failed. It's just that you haven't been recognized yet.
So, you haven't been recognized yet.
No, what if you are recognized for your failure?
That's when they hand out MBA degrees when you fail engineering or medicine or one of your original.
Well, I've been recognized for my failure.
We all have been, yes.
So the moral of this entire story is that we should be better prepared next time with who is going to start the episode.
Yep.
That's a broad takeaway from this. Okay, we should start talking about the topic at hand.
Yeah, so this is actually a throwback to our 2 episodes before this, which was around vaccine passports. And basically there was this news that, 2 of the biggest nightclub chains in England have rejected the plans for vaccine passports, saying they will open on Monday without them. Right? So one guy who's CFC Tom 99 on Twitter said, "My granddad is 75 next year. He didn't fight 2 world wars for this silliness." And obviously, as it is Twitter, some wise guy obviously asked, the First World War was more than 100 years ago. How did your granddad fight that? And so Tom clarified, he didn't fight 2 world wars, as I just clarified.
To be fair, I've seen this template before. It's beautiful. It just works every time. It's such a stupid thing. It still works. God bless some parts of the internet, really.
I mean, and this is the first time I'm laughing at something like so heartily at something that a Chelsea fan has put out. CFC from is Chelsea.
Oh, is that what that was? Oh, I just thought it was some. Oh, fair enough. Okay, now I'm looking at it in different lights. Idur Gudjonsson's club, right? Idur Gudjonsson's club.
Gianfranco Zola.
Gianfranco Zola. Gianfranco Zola.
I thought you said Geo fenced.
I thought he was some Franco who is bought by Reliance.
Okay. Shall we move on, guys, to the topic at hand? Amazing. The nonsense
we didn't know who had the intro for the day. We didn't know who had the profundity. I'm hoping one of us has a topic.
Yes, actually, all of us are extremely, very intimidated by the topic, actually, because you guys will find out what the topic is. And we've all unanimously agreed that we know nothing about it.
Yeah, there's a real reason why we do this early in the morning on a Saturday is because that our incompetence can be masked off as a Friday night hangover, and we are also not awake enough to be embarrassed by what we say.
That being said, a drunk episode of Simplified seems like a fairly decent idea. People who want to see
no one would know.
Yeah,
the difference.
People who want this, please write into
or one where we like smoke a little kadi patta.
That's
hey man.
Yeah, I suppose in Malaysia you take what you get.
Sriket, you haven't
smoked any
right now?
No, I distinctly have not.
Okay. This is just to clarify that Simplified does not condone the use of any.
I'm just 2.5 hours ahead of you guys, so I'm a little more awake.
Yeah, fair enough. All right, let's talk about the topic at hand, ladies and gentlemen. It is a very serious one. It is about the global chip shortage. And I do not mean potato chips.
Yeah, you're right, man. I have not eaten kurkure.
Banana chips.
Yeah.
I mean, actual obscure Twitter references Chip Kitty, which just came to my mind.
At some point in this episode, we will explain what Chip Kitty is, but I think there might be 3 people who are listening to this who might actually understand that. And apart from the hosts, that is. Yeah, this is all Twitter 2009.
This is how obscure, like we've got late 2000s obscure Twitter references on Simplified. I think we have reduced our listener count from 3 to 2 right now.
No, more than anything else, I have a feeling if we continue...
Naren has logged off.
No, I think more than anything else, if we continue down this path, we will reduce our producer count from 9 minutes 30 seconds to from 0 to 1. Out of the 9.5 minutes, I think there's about half a minute of usable material in there, most of which we were silent. Okay, semiconductors, folks. Over the last few months, firstly, congratulations, Sriket, for getting 2 new pieces of high-end technology. He now has a pair of headphones, which is why he can listen to us better now, even if his voice is exactly the same, because our audio engineer has deemed his mic from the headphones not that worthy. And he also has a new Surface Pro. So I say congratulations to you, not just because you've procured 2 amazing pieces of technology, but because you managed to do so during this pandemic where there's a shortage of chips and all electronic items and things like that are being delayed. So what I wanted...
They didn't account for 7/7 sales.
They didn't account for 7/7 sales. What's a...
So just as a side reference, so in India, you have sales. India has a lot of festivals. So there is a lot of sales associated with those festivals. Countries outside of India which don't have these festivals tend to make occasions up. So in Southeast Asia, every double date, 7/7, 8/8, 9/9, 10/10, 11/11, 12/12 becomes a sale.
Okay.
So stuff that I've procured is from the 7 July sale. So there's going to be another one in the 8th August, another one on 9 September. The biggest one is which is called Singles Day in China and Southeast Asia, which is 11/11, which is November 11th, which is the biggest sale in Southeast Asia.
Yeah.
So you get electronics and all that. That's just a random Southeast Asia aside. Please continue.
That's okay. We like giving eclectic trivia on this show. So
if Simplified was part of a conversation, it would be an aside anyway. So please continue.
Yeah, I will try to. So I have been reading a bit about the chip shortage and who makes chips and all that, and went into a bit of a rabbit hole recently. And it's fascinating actually that that microchips, which are so essential to pretty much everything that we do, the way we are recording the show, the way we are logging in, the way our throngs of fans are listening to us, everything has to do with semiconductors, whether you're an Android guy or an Apple guy or, whatever you choose to support. Everything ranging from your phones to your microwaves to cars to everything has chips in them. And what's so surprising to me is that there are only a few companies that actually make semiconductors. It's like vital cogs of chain. It's not like if Intel conks today, honestly, nothing's going to happen. But if there are a couple of companies, if they conk off, then the entire world is going to pretty much come to a standstill, or rather nothing is going to be created.
Chuck, quick question. On semiconductors, when you're talking about semiconductors, these are not just your processor chips, right? You're effectively talking about semiconductors being in your microwave and your washing machine and your fridge and stuff like that as well, right?
Yeah.
So when these are integrated circuits, basically you're talking about any kind of integrated circuit.
Yeah.
So when you're talking about a semiconductor shortage, it's not just your electronics and what you deem to be your screen devices that are getting affected, but you're also like your run-of-the-mill fridge, microwave, mixie, all of those things as well.
Yes, this is the most intelligent, non-scripted question that has ever been asked on this show. So well done, Sriket. Your award will reach you by mail shortly.
Integrated Sriket.
Integrated planar Sriket, actually.
Yeah, that's part of my designation. But
so that's another story for another day. So let's start right from the beginning. What are semiconductors? And thankfully, we have 3 engineers on the show who will explain everything. And Sriket, who's likely to supply the correct answer.
Please educate me, engineers.
I'll give the callback answer, which is that semiconductor is the OG middle bencher. It couldn't be a conductor. It couldn't be an insulator.
Yeah, that's actually fantastic. That's a great way of putting it. Yeah.
Sorry, it couldn't be a conductor. It couldn't be a
insulator.
It's classically in between.
Yeah. Nice. So without getting too much into science, that's exactly what it is. Semiconductors are materials that are in between, and by tweaking things like voltage, light, heat, and things like that, you can make a semiconductor either a conductor or a non-conductor insulator at any point of time. Of course, if it's a non-insulated state, it will not ask you for your ticket. So, which is why it's a semiconductor state.
But also I think we should touch upon the benefits of doping and middle bench.
Yeah, go for it. This is all yours.
Naren, I think, will do a better job.
Yeah, Naren, the real engineer.
So, I'm a mechanical engineer, which means I don't know anything about anything. But let me sort of take. So, semiconductors, like people, work, start zipping around electrons if you dope them a little. So you can change the behavior, and you can dope them like human beings with different things. And they behave pretty much the same when they are doped with anything. And there are different it is very clever actually. I mean, I've been around. Like we used to have a basic electronics course in the first year of engineering, which had no semiconductors. It was vacuum tubes only.
Yeah.
all the diodes. I think diodes was solid state, but all the other, the amplifiers, everything were vacuum tubes, because this is 82 and semiconductors were still pretty cutting edge, too cutting edge for first year students to study. And we have come an enormous way since then. It's all by introducing a very, very, very small impurity. You change the behavior of the thing, and then you have junctions and the whole deal of quantum mechanics that goes on there. And all you're able to do is control the flow of a small current. And you sort of put everything together and you get everything, the computing devices, power supplies, gates, every single thing. I just find it mind-boggling.
Yeah, it is mind-boggling actually. When you go down to like a single transistor, what it can do. So semiconductors are used to make transistors, and transistors at their most basic, I suppose we can call them a switch, which can controls the flow of current and all that. And on Wikipedia, on YouTube, you will see these experiments where people are actually making real-life transistors, or actual switches, and the amount of effort it takes to create a simple transistor that can switch on and off a light, or power on and off a light when heat is applied to it. Now imagine that very same technology shrunk down to the level of nanometers, being able to make, say, Zoom video conferencing possible, or letting planes fly around the world and things like that. It's kind of fascinating, really. It's like the same technology applied at a much smaller scale. And these materials called semiconductors make that happen. Semiconductors are made from, it can theoretically be made from a lot of materials, but the most commonly used one, of course, is silicon, because it's one of the most abundant materials in the world. So this makes it practically convenient. Interesting, you mentioned vacuum tubes, Naren. So one of the first computers to ever be built, I think it was the first computer to ever be built, was the ENIAC, which had 18,000 vacuum tubes. And it was capable of doing a calculation that would take a human 24 hours in 30 minutes. The only problem was you needed a full room and I think about a staff of 20 people to run it and make it work. So, and tubes needed to be replaced all the time. Semiconductors could go on forever, etc. And the revolution really started from there, right? Like from the mid 50s onwards, and is just gotten better ever since. Have I got that right, Naren? While I scramble through my notes for the next.
And some interesting thing, the guy who invented the transistor, William Shockley, he was also brought, a lot of, he brought a lot of disgrace upon himself. Or he's sort of, do you know why?
No, but I
he was
know your
famously or infamously, he was a proponent of eugenics. So Shockley was a pretty bad guy. And
that's ironic that an entire technology that depends upon introducing a little impurity into it, his founder was actually very famous.
Awesome.
That is the actual profundity of the show. Very nice, very nice. Transistors, of course, was the most successful of two sibling technologies, the other being trans brother. We will move on from there.
We wanted that.
Wake up. Yes. No, I think the term Silicon Valley itself was coined in the 70s or something.
Yeah.
But so by 80s, I guess semiconductors were around. They were just like the syllabus was laid to it.
Let's see. A modern phone has around 2 billion transistors, and the entire process of how these things are made. So what I want to do is, and now that we have got the difficult science section out of the way, I've been looking at how these companies make semiconductors, and that will then lead to why we are leading to this, why we have this shortage right now. We should take a bit of a break before we do that so that I can recap my notes as well. So let's do that right now, gentlemen.
Yes.
Get some chips.
Hey, everybody, let me tell you a little bit about what happened on the IVM Podcast Network this week. We've had some amazing stuff, right? I don't know if you're aware of the redoing or the rebranding of the Traveling Professors show. We called it now Smarter with Sid, which is our Deshmukh. This week he examines Netflix getting into e-commerce, and will this affect how Amazon's dominating the space? Also, let me give you another quick hits to join up on. So on Cyrus Says, Cyrus was joined by Olympic equestrian Imtiaz Anis, and Nishan Budla from the Triangle Offense podcast showed up on Thursday's Cock and Bull to talk about the NBA Finals. On Nankari Sadaf and Archie were joined by Keshav Chaturvedi of the Tere Mere Raste podcast. On Storytellers and Storytellers, Vineet talks to Ashim Mathur from Dolby. And don't forget to follow us on Facebook, Twitter, LinkedIn, and Instagram to keep up with what's going on the network. And with that, let me also just finally thank our sponsors. They're what makes things possible. We'd like to thank CIET, Cred, Global Victoria, Bank of Baroda, Intuit India, and Lenovo. Thank you so much for making this possible.
So welcome back, guys. Assuming that everyone is undoped and alert. We were talking about semiconductors and the doping of silicon, which makes it so.
Yeah. So this is an entirely fascinating process. So silicon is a thing that's used most likely. Sorry, I'm not going to be looking at the camera because I'm trying to pay attention to some notes that I've written over here, which are honestly more notes that I've actually made for this episode than I think my entire electronics exam when I was in engineering. So silicon is taken and it is it's turned into these ingots. It's actually beautiful, nice, big, shiny things about the size of, say, a medium-sized dustbin. And that is called a silicon ingot, and they are cut into very thin wafers. And then what happens is it goes through a number of various machines that basically, there's no other way to put this, print the integrated circuit onto it. Yeah. And that, I guess, I'm skipped over a lot of things, but that in essence is what it is. What's interesting about this whole process, though, is that there are different teams that are involved. There's one team that's involved in designing the chip, because it's not like all chips are the same. Like a mobile phone manufacturer might want a chip doing a certain thing. Somebody else who's making it for a car's entertainment system will want something else. Somebody who's using it to, say, use drones for warfare will need it for another thing. So all chips are sort of like different. In that sense, it's also integrated. That's an integrated community diversity. No? Okay, no. I'm sorry. That didn't work out very well.
That was not in your notes, no?
That was not in my notes at all. I just looked at Sriket and I wanted to say, just looking at, I wanted to say. So what ends up happening is on one of those wafers, one of the round wafers that comes from the ingot, which is cylindrical, there are hundreds of chips that are printed onto each of them, and then they get sawed off, and then they get assembled onto the actual circuit, which is going to be used in phone or drone or wherever it is. So it's kind of fascinating that everything from a small electronic toy to the new headphones that Sriket has to complicated systems that control, say, like the energy sector, all of them have chips coming from essentially this exact same process, which then brings us to next question. Who makes semiconductors? There are some companies that we know and love and associate with as being chip companies, the most prominent of which possibly is Intel, who in many ways was responsible for this entire revolution. In fact, it was one of their earlier scientists, Mr. Moore, who said in 1965 that the number of transistors on an integrated circuit will double every 2 years, basically meaning that processing power will improve every year. And technology has been trying to keep up with the law, which kind of seems to be like a little foolish endeavor. Just in order to preserve a law, they're trying to push more and more circuits inside, more and more transistors inside a circuit. But hey, that's fine. So that's Intel, which designs and manufactures chips. There are other companies that I'm sure you guys know, which is Qualcomm, which specializes in mobile. There's NVIDIA, which has made a name for themselves in graphics. And recently enough, in cryptocurrency, they found out that NVIDIA's graphics card chips are strangely good for cryptocurrency mining. And then there are some specialists. There's a Dutch company called NXP, which builds chips for in-car entertainment. But apart from all these, so all these companies, they design their own chips. Intel manufactures some of their chips, and Qualcomm just designs chips and outsources the manufacturing, which now brings me to a fascinating company called TSMC. Or TASMAC, yeah. Not to be confused with each other. At this point, we are going to do something unprecedented in a simplified episode, and we are actually going to play an episode from another podcast altogether within this. Hopefully, some of you guys have heard this, but if not, now would be a good time to check this out.
Episode 33, the company without whom nothing would happen. This is a different kind of story. Yeah, I know I say each story is different, but this is a different kind of different. Because you probably haven't heard of the company I'm going to be talking about. But If it weren't for them, life today would be very, very different. Indeed, one of the company's biggest clients says there are very few companies that I know have had as great an impact on society today. So let's get into this then, even if you don't know the company name. Maurice Chang was born in China in 1931. At an early age, he harbored dreams of being a novelist or a journalist, something he was dissuaded to doing by his father. At the age of 17, he moved to Hong Kong at the height of the Chinese Civil War and a year before the PRC was established, the People's Republic of China. In his young life, he had already seen the unrest in China and the Japanese attacking Hong Kong after their little adventure at Pearl Harbor. This was the beginning of an interesting international journey for Maurice Chang, who went to Harvard. While at Harvard, he still dreamt of becoming a writer, but he transferred then to MIT, where he read that specialized technical training would improve his job prospects. And from here, he would go on to work in some prestigious companies, including Sylvania Electric Products, Texas Instruments, and General Instrument Corporation. It was the most recognizable name in that list, the second one, Texas Instruments, that he built up his reputation, really, leading one of the group's most ambitious and important businesses, Semiconductors. Maurice was also credited with a controversial idea at the time, pricing semiconductors ahead of the cost curve, which, when translated to English, meant willing to let go of potential short-term profits to get market share, then scale up and then make greater long-term profits. All in all, Maurice and Texas Instruments were quite a big deal in the semiconductor world. And later, much later, at a speech at Stanford where he was felicitated, he would say that there was an old Chinese poem which loosely translated as follows: when you reach the top, you look down and then you would see all the available roles or jobs. Maurice said that at the height of his semiconductor career with Texas Instruments, he looked down and he couldn't see any new available roles. So, as he says, he needed to invent something, a whole new business model. He realized that all semiconductor companies at the time would do everything. What were those everythings? Designing, making, and selling. So he thought, what if I just take the second part of that, the making part of it, and focus on just that, leaving the designing and selling to somebody else. In his words, it was a solution looking for a problem. Because at the time, nobody needed to outsource this one small portion of their semiconductor business. But that would change. You see, semiconductor companies that would do only the design aspect and not the making aspect were called fabless companies, F-A-B-less companies, fabrication-less, without fabrication. Maurice's new business model worked well for these companies, and soon his business model, which became known as the foundry model, turned out to be quite a sweet alliance with these so-called fabless companies, which were growing in number and specialization. This coincided quite nicely with Maurice's new role. He was recruited to be part of a government-sponsored non-profit to promote industrial and technological development, not in the US, not in China, not in Hong Kong, but Taiwan. This was fortunate because with increasing needs for semiconductors, more companies in the West were looking for outsourcing their manufacturing, that second part, to Asia. Indeed, in 1985, when Maurice came up with the foundry model, there were but a handful of these fabless companies that needed to outsource only the making part. By the time he started working in Taiwan, he says that number went up to 20 to 30. That ballooned to hundreds a decade later. Today, the company that Maurice set up, Taiwan Semiconductor Manufacturing Company, or TSMC, is the world's largest semiconductor foundry, manufacturing 10,761 different products using 272 distinct technologies for 499 different customers in 2019. It is Taiwan's largest company and the world's most valuable semiconductor company. Among its customers are names that you would recognize: AMD, Apple, Huawei, Sony, Broadcom, MediaTek, NEC, Fujitsu, Qualcomm, and I could go on and on. Why? Even companies with their own manufacturing facilities still outsource some part of their making process to TSMC, including chip giant Intel and Maurice's old homestead, Texas Instruments. They make chips for everything from smartphones to appliances to even fighter jets. Maurice Chang is now called the godfather of computer chip manufacturing, and while you might not have heard his name, it's quite likely that without him and his expertise, many of the other big names in tech that you might be more familiar with and whose quotes grace the walls of your conference offices wouldn't be as famous. I know this is a different kind of toot episode, not one that involved a grand reveal at the end of a brand that everyone is familiar with, but it's the story of a company, an unsung hero, quietly powering so many aspects of our lives today, including what I'm using to record this podcast on and what you're probably using to listen to it. And for that reason alone, I wanted to share it. Who knows how many other such technologies are around and how many are yet to be formed that will change the way we live in 5, 10, 20, 30 years from now. Something as innocuous sounding as decoupling the manufacturing process from semiconductor chip making, for instance, transformed the world. In the beginning of this episode, I shared a quote. Remember, there are very few companies that I know that have had as great an impact on society. That was said by a compatriot of Chang's, Zhenjun Zhang, if I got the pronunciation right, founder of the graphics processor maker NVIDIA, also from Taiwan, also one of TSMC's oldest customers. And another quote of his at the time, at the same event, is worth repeating. Pretty much everyone has a TSMC made product in their pockets right now. They just might not know it.
And that was my toot episode about TSMC. Sorry for subjecting you guys to that, but I thought that would be a decent introduction to what we're talking about. Any thoughts on TSMC? Or, have you heard of this company? By the way,
No, I hadn't. Not.
Wow,
not
I'm surprised
right
you
now.
haven't.
Yeah, no,
I've heard of it only in the context of the shortage, and that's when I realized that there's drought in Taiwan, and like water is one of the major necessities for semiconductor manufacturing.
Yeah. In fact, TSMC and Taiwan, I mean, it's like the crown jewel of the economy. I think half the country's R&D budget comes from this one company. There are lots of like little stats like this you'll find.
It's like Nokia for Finland.
I think Finland has a lot of other things. Sure, because the most iconic company, I guess, that's come out of there. But I think Finland has a lot else going for it.
It's like Bevco for Kerala.
Yeah, fair enough. All right. I think that weirdly enough is a much better analogy. Oh, goodness. Bevco and Asmc in the space of 10 minutes. I never thought I'd live to...
More kosher being Amul for Anand.
Or Amul for Anand, sure. Or Reliance for Jamnagar, wherever.
That too, yeah.
So, TSMC is such... So
Tata for Tata Nagar.
Tata for Tata Nagar. Fair. I think
we've established the template.
We've established. And in fact, the government of Taiwan had even requested TSMC, hey, you guys are using up too much water. So is it possible to save on that? So it's become part of their goals and stuff like that.
And TSMC said, Chip Kitty.
For those who are confused,
you have to really explain it now.
Yeah.
I actually don't know. I mean, I know it's something like Chup became Chip, but the rest of it I just keep.
And Kitty had a more canine
beginning. Yeah, so Chip became Chup and Kitty was more canine.
There we go. Yeah. So this is what we used to do on Twitter back in the day, kids. This is what you missed out on. So anyway, that was TSMC. TSMC, I think, is a fascinating company. They are by and far the biggest chip manufacturing company in the world. Taiwan, a huge part of Taiwan's exports comes from this company. Everybody gets their chips manufactured by these guys, and hence the fabless. So you have companies like AMD, NVIDIA, etc., that only do the chip designing. They don't have their own fabrication. Hence, they are called fabless companies. Whereas companies like TSMC, they don't have the design part of things. They do only the manufacturing. So they are essentially, they are contract manufacturers for everybody. And they have a stated policy of not ever competing with their customers, which is why they don't get into their own branded consumer-facing chips. This is actually quite interesting because Samsung used to supply chips to Apple at one point of time, and the relationship was actually quite decent. But then Samsung started getting into smartphones on its own, and that kind of like cheesed Apple off a little bit, or at least they felt uncomfortable that their key competitor was also making components, which is why they diversified. They found TSMC. There are stories of lovely partnerships and how, both parties have sort of grown together. TSMC and Apple are definitely that. Apple's has constantly pushed the edge in terms of, pushed the boundary in terms of what they want to do. And that has had an impact on TSMC as well, which has been forced to adopt new technologies just in order to keep up with Apple's ambitions. And obviously it's been able to translate that expertise into a lot of other clients and a lot of other business as well. TSMC is a huge company. It's a $300 billion plus company. It's the largest semiconductor manufacturing company in the world. They have pioneered, or at least they have managed to get chips down to a ridiculously small size, 7 and 5 nanometer technology. Yeah, I mean, they just keep increasing the transistor density, reducing the power. They have a huge spend in R&D. And now they have started investing in manufacturing units in other countries. In fact, they just started a unit in the US as well. I think it was in Arizona that they did that. And all this for a company that just started in 1987. So it's kind of interesting that you have a manufacturing unit. It's not a software company like Facebook or Google, but a manufacturing company that's just that's younger than some of us over here. Actually, all of us over here.
I passed my engineering in 1986.
There you go. That's why you didn't have the transistors with you in 82. They interestingly also have an office in Bangalore, but I'm not quite sure what they do over there. Maybe it's just a business development outfit. So yeah, what else do I have over here? So 2014 was when this association with Apple came about with the iPad chip. And today Apple represents 23% of TSMC's revenue and Huawei is a distant second. Many people have speculated as to whether Apple will actually end up buying TSMC given how important it is. I mean, they're single manufacturer. They're a single manufacturer of chips for Apple. And the internet has a lot of debates like, will Apple buy, discussions and speculation, will Apple buy TSMC? But the answer is unlikely because, I mean, then they'll have to deal with Apple probably won't want the headache of dealing with all the other companies that all the other clients that TSMC has, and the Taiwan government is likely to block it. It's too valuable to Taiwan as a country to give TSMC up. Interestingly enough,
it's also used in the auto industry and stuff, right?
Yeah, it is. Yeah. Sorry, I should have mentioned that it's not just these. It's not just computer manufacturer chips. They also make for a whole bunch of other. They also manufacture for a whole bunch of others as well. Also, it is the electronics chips manufacturers that represent most of its business. Now, along with TSMC, there's another company. Again, one of those, if you remove this company, then everything would collapse sort of thing. And this is a company called ASML, which is a company that's based out of a small town in the Netherlands. What they do is they make a lithography machine, which is a key part of the semiconductor manufacturing process. What exactly it does, I have forgotten, and unless Naren can quickly salvage that.
Yeah, so the whole thing about doping is that, you have to introduce the impurities at exactly the right spot. What I believe is done is a very intricate sort of JPEG is projected onto this thing. It's coated in photoresist paint, and then you sort of project the image onto it, and wherever the image is, the paint cures. Wherever it is not, it's not, and then you dissolve it so the paint dissolves, and then when you dope it, it goes only in places where the resist isn't there, or something like that. Yeah. And this is at nanometric scale. So they're like, the size of the molecules themselves. So it's incredible. It blows my mind. So I don't know how they get it to be that sharp.
Yes. Yeah. And you're not the only one wondering, because this company, ASML, is the only company in the world that actually makes these machines. And they are actually fairly expensive. They cost around $150 per machine. So it's not like if you and I wanted to start a semiconductor company today with one client, that's going to be difficult because you need a certain amount of scale.
150 what? How many
$150 million? $150 million. Okay. In fact, I think, like, for example, I mean, there aren't that many of them sold either. Like, I read somewhere that TSMC has placed an order for 40 of these and Intel has placed an order for 20 or 30 of these. So it's only at that scale that even these things can be manufactured. And it's not like ASML themselves can easily set up. So all these things are massive scale sort of things. You can't like have a cheaper version of this or something like that, right? Which is why it is very difficult for, even though it's a highly profitable business, there aren't that many companies actually with the capability to come out with chip manufacturing. You can say that, oh, TSMC is the only company doing this, so why don't we set up in the US? It's not that easy. It takes at least 3-4 years for a foundry to be set up and with the latest technology, because you're not starting from scratch, right? You're starting from, say, 7 nanometer, 5 nanometer technology. So it needs to be at that level. So it's incredibly expensive. All this means that if you can, you should buy shares in both ASML and TSMC, because these two companies are going nowhere except up. ASML, interestingly, started off as a division of Philips, or Philips was one of the partners back in the day. Hence, I suppose it's Dutch roots. Its initial competitors, interestingly enough, were imaging companies like Nikon and Canon. But Nikon and Canon couldn't keep up with the improvements in lithography or the so-called EUV technology. There was lots of R&D that was put in, huge risks were taken, and today it's come out with the machines that, the only machine really for lithography, the process that Naren just explained, that these guys, that chip manufacturers are on the company. So Intel, for example, wants to start manufacturing more chips. Now it has to place an order with ASML to get one of the lithography machines or 20 of its lithography machines so that they can start competing. So that's really, so I find this fascinating, right? We have like so many thousands and thousands of brands of phones, microwaves, cars, computers, everything. And at the heart of it are these two companies, one located in Taiwan, one located in some remote part of Holland, without whom none of this would happen. Like you can say, okay, if Huawei is not available, I'll buy a Xiaomi. If Apple's not available, I'll buy a Samsung. But without these two companies, you can't, none of this would ever have happened.
It's the clothing equivalent of the button and zip company.
Yeah, in some sense, yeah. But even more difficult, because you're talking about sophisticated machines over here, which you can't find an easy substitute for. And you can't zip it up or something like that. If you don't have buttons, you can still introduce something like that.
Or safety pins.
Or safety pins. Please don't say Bevco now again. Which brings us to the shortage right now that the world is going through in terms of chips. So quite simply put, when the pandemic hit, the demand for everything went through the roof, because we needed more computers at home, more devices for either for work or for recreation. We decided to game more at home, or companies were buying laptops and shipping them to employees. So all that. So people were buying webcams for the first time in 10 years. And all this meant that lots of electronics were needed, which meant chips were needed. And TSMC has been extremely good in predicting demand and supply. And even that industry does go through some cycles, like during New Year's and all that, there's going to be a demand because of the gifting season and holiday season and all that. They've been extremely good at optimizing their production, their output. But even they couldn't have seen something like the pandemic coming, which just threw everything out of the water. They are expanding capacity, but it's even that is going to take at least 3-4 years. So if it's going to take TSMC that much amount of time to set up a new fabricating unit, then you can imagine how difficult it is for anybody else who doesn't have action in this space. That being said, Biden is very keen on building some sort of capability at home. China, of course, has been trying to become more and more have some sort of domestic capability for that, although they will argue that
Taiwan is
exactly.
China.
Yeah, exactly. Although they will argue that Taiwan is domestic for them, but whatever. So the Chinese government has earmarked $2 trillion for R&D for chips at home, which is like staggering amount of money. And the interesting thing is, this is not going to stop, because even the traditional parts of the economy that don't need chips are going to start needing chips once 5G starts kicking in. Cars need more chips than ever before, because now you have all sorts of features coming in, if auto driving and all that is coming, electric vehicles and all that. So the demand for not just chips in volume, but also more sophisticated chips that have different capabilities is just going to keep increasing. And there is only so many lithography machines that ASML can make, and only so many chips that TSMC can make immediately. It's not like it's not like advertising. It's not like advertising. No, you can't say like just make the same machine make.
Yeah, basically, I think what these guys do to predict demand is just go to just have an aside with all the CES fellows and see what is the newest thing people are putting Bluetooth in.
Yeah.
आज कौन सा संडास, hair dryer, किसमें Bluetooth लग रहा है?
किसमें Bluetooth? Yeah, absolutely.
And then they're like, हाँ ठीक है, इसके basis पे अभी इस साल का demand like 60% बढ़ा हो.
Yeah, and essentially that is about it. I think this whole episode was just to say that we are going to chips are very important. Semiconductors have transformed the way we live and work, and there are two companies at the heart of this entire thing, which you have most likely never heard of.
I'd say one point which maybe we're missing, especially when you look at semiconductors, and I got a bit of this understanding working on B2B stuff, but I think the biggest use of semiconductors and chips are more in terms of setting up connectivity on a B2B level. So building server farms, those are the biggest uses of semiconductors right now, because again, with the global, general progression of technology even prior to the pandemic, but now like entire people's livelihoods are dependent on the functioning of server farms. Right. Like, it's that much more important. So from a B2B perspective, and server farms are just expanding, like massive new server farms are being built every other day. And so for that, if you're not able to develop that capacity, and if you're restricted by either cost, because of course demand, when supply is low, the cost will go up. And with that, if you're having a consumer, when the consumer is facing expense side price rise, then on that side, that will become a major hurdle to this whole remote revolution we're going through.
In fact, the semiconductor shortage has also accelerated the push towards cloud, right? So you don't need to sort of plan for your own, local systems and stuff like that. So the cloud technologies manage everything. So in fact, this is another one of those reasons why cloud is big now. It's already fairly there's huge momentum, but this is another reason for it.
I also discovered something interesting, which I think can be an episode unto itself, is all about cloud gaming in some way, where you can pretty much, you need to have an LCD screen and a processor that runs basic OS stuff. But the entire, the lack of, you don't need that advanced gaming chip. You don't need any of that. You just need a strong, stable internet connection. And your entire processing is happening remotely on a much better system somewhere else. But so that with their entire thing and the cloud revolution also, the entire thing about server farms and connectivity is massively increased. So I think just like in some ways drawing a parallel with healthcare, where you're moving to like centralized healthcare systems. This is also centralized computing systems where like larger companies will like kind of do that bargaining power, and services of computing will be offered on a cloud level, on a more subscriber level rather than purchase level.
For me, like the one thing that the moral of this story, as it were, really was the power of decoupling this decentralization, or rather specialization, right? You have like companies like AMD and Qualcomm and all saying, okay, we are going to focus just on design. Let's just understand the consumer. Let's just design the crap. And they have world-class design. ARM, for instance, which now designs Apple's new chips, just focusing on design. And you have another company that just says, we are not going to bother about design at all. We're just going to focus just on manufacturing. We don't care about what you are using this for or whatever it is. So that's kind of interesting, like the whole separation of things. And the second thing is, when I was reading about both TSMC and ASML, one thing that stood out is both the companies took a lot of risk in terms of investment, in terms of R&D. We're talking about the tunes of hundreds of millions of dollars over here, which really helped them be successful. So there's a moral of the story in there somewhere, but I'm not able to. Exactly. So invest in R&D if you want to become the TSMC of your own life, I suppose. Something I'm not able to find.
Very profound.
But what's the...
or invest in R&D, which is rum and daru for Asmc.
Tony?
No, I was asking, what is the automotive story? Like, why is there... I think prices of automotive stocks, etc., have crashed majorly because
it's affecting the supply chain a lot. So automotive has dozens of electronic control units. So there'll be one which is in charge of your window winders. There'll be one in charge of your wipers. There'll be one which is central, which monitors your engine, there is one for the AC, the temperature, everything. They've put electronics into it. Yeah. And they've done basically to make a fancier system at a cheaper price. Yeah. The problem is the whole thing has become very sophisticated. It's all because they wanted to make it cheaper. Everything is squeezed onto a chip or a very, very small card. And if that chip doesn't come, your car doesn't roll out. So a regular car has some 5,000 components in it. Yeah. And literally, if there are 4,999, your car doesn't.
Yeah. No, I'm sure they will be
screwed big time.
Yeah. I'm sure there'll be stories like the car is entirely manufactured, but because of one chip pressing the conveyor belt, that piece missing. I'm sure there'll be lots of weird B2B stories like this.
Yeah. No, I was just saying who called it semiconductor shortage and not chips and dip. So.
All right. And with that, I think that was what we were waiting for. So that's a lot of terrain that we have covered in this episode, from Asmc and Devco to that delightful comment by Tony right now. Hopefully, we have all understood a little bit more about the semiconductor industry and the shortage and all that. Yeah. I had a blast researching this episode.
Learned a lot of new things. So
and relearned things like PNP junction and things of that nature. So Naren, shall we wind up as always?
So stay safe, stay chippy.
Doped. Okay, I was going to say, I was expecting you to say stay doped, but that also works.
I should have, Stay doped, stay chippy, and stay simplified.
Yeah, and stay integrated with your circuits.
Eventually, you'll see the end of your childhood.
Get accustomed to womanhood.
Enjoy the experience of sisterhood.
Might get to wifehood.
Or not. Choose motherhood.
Or not. You'll learn to define your personhood.
Earn a livelihood.
Change the neighborhood.
And get rid of the falsehood that life post-academia is easy.
So join me, Ritasha.
And me, Ayushi.
On a journey from station starting point.
To station, what now?
Next station, Pudin station. And hopefully, Agla station, adulthood.
Fresh episodes out every Thursday.
Namaskar, dear friends. My name is Ashish Vidyarthi. Life, as you know, is a journey. And you and I, travelers, how can we celebrate this travel? I have a podcast for you, Begin the Journey. I share stories and moments from my life. Do tune in every Monday and Thursday to listen to my podcast on the IVM Podcast website, app, or wherever you get your podcast from. Cheers.